30 people in attendance here. Welcome everybody to the monthly ESIP Interoperability and Technology webinar series. This is the second one that we've had now, co-hosted by Ethan Davis at Unidata and myself. And just a reminder that the Interoperability and Technology page is here. If you just Google ESIP Interoperability, you'll probably land on this page. And the activities, if you click here, you can get to this several ways off the ESIP calendar, but you can also go here and look at our webinar series. To see what has come before this talk, you can go and watch the recordings or look at the slides. Last time we had leaflet time to mention. Next time we're having Ken Casey give it one-stop talk. Note that that's on a Wednesday, not the usual Thursday. But today we have our talk today, Dive into Docker, is from Kyle Wilcox, Dave Foster, and Shane St. McClare from Axiom Data Science. These guys are all work for this, Axiom Data Science is a contractor that's been doing a lot of work for, well, they do a lot of work for a lot of organizations, but the one that I'm most familiar with is the Integrated Ocean Observing System. So a lot of people have been asking about, curious about Docker, and I guess since there's 36 people on the line today, it's an indication that there's a lot of interest in Docker, and it really is, of course, taking the world by storm. And I'm just going to turn it over at this point to, I guess it's going to be a shared presentation by Kyle, Dave. I guess Kyle's going to go first, and then Shane and Dave, or something like that. So I'll pass it over. Let's pass it over to Kyle to kick it off. And I guess, oh, and everybody's muted, so Kyle will have to, you have to unmute yourself. Let's see. So I'm going to make you the presenter, and you should be good to go, Kyle.
Can you hear me now?
Yep.
Can you hear me now?
Yes.
Okay. Okay. Should see my screen now.
Looking good.
All right. Thanks for having us. I'm Kyle Wilcox. I work for Axiom Data Science. As Rich said, I'm a software architect here. Quick overview of what we're going to go through today. I'm presenting with Dave Foster and Shane Sinclair. They're both going to give some demos after a 10 to 15 minute introduction by myself. Dave is going to do some more advanced Docker techniques for managing and orchestrating lots of different containers on an infrastructure. And Shane's going to give a more basic Docker workflow and technique demo. At the end, I assume we'll take questions. So hold your questions till the end. Like Rich said, everyone's muted. First, to get going, we're from Axiom Data Science. We're an informatics and software engineering firm based in Anchorage, Alaska. We have satellite offices in Portland, Oregon, and Providence, Rhode Island. We specialize in data management services, chemical, environmental, biological, physical characteristics of basically the planet. We have about 16 employees spread over the country. And as Rich mentioned, we've been heavily involved with USIUs since its initial Oceans.us initiative in 2006. We run the data management teams for 3 of the 11 regions, Alaska, Central and Northern California, as well as Southeast Atlantic. We run 2 data centers in Portland, Oregon, and Providence, Rhode Island that we'll touch on today, and how we use those, how we use that infrastructure kind of to organize our Docker containers and services out to the public. So what is Docker? We get this question a lot. It's a technology that allows you to wrap up everything you need to run a program or application or service into a single container to move it efficiently and to run it efficiently, no matter the operating system. You could kind of make the connection between the shipping containers in the 1960s, before they standardized on the shipping container. Every aspect of the supply chain and the distribution of goods had their own specialized techniques for transport, for offloading from ships, unloading to trucks. And Malcolm McLean in 1956 patented what later became the standard for shipping containers. So what do those shipping containers allow everyone to do? Well, reduce costs. They eliminated special handling for individual pieces of cargo, improved reliability, reduced theft, and slash inventory costs by shortening transit time. Take that same idea of shipping containers and apply it to the software world, which is what Docker is. You package up everything you need to run your application into a single container, and it can be run anywhere by anyone and customized in a way where it's run how they want it. Internally, Docker only manages maybe your code, your library, and your services that you need to run your application, and it externalizes all the logging, monitoring, and network aspects of your application. That's the main benefit Docker brings out of the software world. Now you might be thinking, well, this kind of sounds like a virtual machine. We've been doing that for decades. The difference between Docker and the virtual machines are virtual machines have their own operating with their own memory and CPU management. The host computer that you run your virtual machines on emulate those computer resources to each guest OS through a hypervisor. And through that process, it imposes the measurable overhead in the virtualization layer. So you take a performance bit, and it varies based on, hypervisor and OS that you're running. Docker containers are executed within a Docker engine. You could think of that as a replacement for the hypervisor. And there are no emulated resources. It is using the bare bone resources on that machine. You get better performance and greater compatibility with the host resources because they're not virtualized. VMs can take tens of minutes to spin up depending on the VM, or Docker containers spin up fairly instantly in seconds. It is a container, so everything's packaged and run on top of your existing OS and kernel. I like to stress that the technology is not mutually exclusive. It is very common for people to run the Docker engine in VMs. So you kind of get the best of both worlds. The VMs provide an isolation at the hardware layer. So some enterprise systems, some government organizations are still going to require that sandboxing of hardware. And Docker containers their isolation level is more at the OS process level or the application layer. That's another way to think about it. So the basic life cycle for a Docker container. So later on, Jane and Dave are going to get a little more in depth. So I'm just going to breeze over this, and they will revisit it later. So if you want to raise your hand for a question, try to hold off. You basically write a Docker file, which is describing your application. It can describe anything you'd like to do. You can copy files into it from your local machine. You specify which ports are available, how to start your application, like what programs inside of that container do you want to run. That's kind of the first step. Once you get your container built, you'd like to submit that container to a registry. Why would you want to submit it to the registry? Well, you can run things directly from a registry. So once something's built, you can run it on that local machine, and that's cool. But you want to be able to run that in a cloud or on your own infrastructure, or share it with a friend so they can run it. That's where the registry comes in. You can run anything on a server. You can run it on a laptop. As long as Docker engine is running on a machine, you can run any container that's hosted in a registry. There's a public registry at hub.docker.com, which is kind of the equivalent of GitHub for source code. You can kind of submit your containers there. People can comment on them. You can link it with GitHub projects, so you can get some integration with how to build it. You can also run local registries on your own infrastructure. For example, at Axiom, we run our own registry here, and we gain the advantages of speed because it's a local network. Now, those two steps is someone who is creating containers and creating Docker files to do. The vast majority of people are just going to be running Docker containers, and this is where the power is. If you're just interested in running other people's images, this is all you need to do. It would be one command. You run it directly from any Docker registry, any container that you can find. It does require reading some documentation on the container you want to run, and you should also treat any Docker container you want to run as you would any other random file you would download from the internet. You don't necessarily want to just Docker run something you get email. Here and check it out.
Hey Kyle, just you can point with the mouse if you want.
Oh, you can see my cursor.
Yeah.
Cool. I guess you're suggesting I do that. So a quick use case that I thought would be applicable to this group. A lot of us are earth scientists or small shop software people. There's not a lot of enterprise level IT. people in the earth sciences that I've had to deal with. And over the years, I've had to manage various Tomcat instances all over the world through private, public, academic institutions. But Tomcat is an extremely robust system, and I don't understand all of the capabilities. I only understand a small fraction of the capabilities. But in the past, we've spun up installed a hardware machine, spun up a VM. Inside of that VM, I just kind of Google and figure out what things, if I want to run Tomcat, do I have to have installed. There's APR configurations, there's SSL configuration, there's different logging techniques. Do I install the management web apps? Do I want remote JMX monitoring? How do I performance tune this Tomcat instance to run my application? And at this point, I honestly don't know what I'm doing. So I used funded Rich Fignell 7 years ago to go around the regions and install Tomcat and install threads to kind of get all the regions on a level playing field. Well, after 7 years, grad students had just steered and services started to degrade. And it was mostly due to kind of no one being an expert on how to run Tomcat and how to run threads. So there must be a better way, right? So what the talk is about is how Docker can kind of replace that void of letting the experts in Tomcat, in DevOps, and IT administration manage what they're good at, and letting the earth scientists get on with the science and manage what they're good at. This is 2 examples on Dockerfiles that are out there in the wild right now that we've built. On the left is Tomcat, and on the right is Threads, 2 fairly popular applications that we use in this community. I'm not going to get too deep into the Dockerfile. I think Shane's going to get there. Think of Dockerfile as kind of programs on how you want your container to be built. It's limitless. You can run any system command. You can download things, copy files, etc. If you notice here that the Threads image is actually inheriting from the Tomcat image. So what this allows you to do is the people who are the authors of the Tomcat image can focus on developing Tomcat and getting that image up to par security-wise, user-wise, documentation-wise. And additional applications can come along and base themselves on that Tomcat container, which is what this Threads container is doing. Really all it's doing is downloading a WAR file and deploying it inside of that Tomcat container. The separation, is really great. It allows, like I said, experts to focus on what they're good at.
Just to clarify, Kyle, then, you don't need to install the Tomcat container. You just install the Threads container, and it itself uses the Tomcat container, right?
Yeah, right. I think this slide will get. I think I'll skip this. I'll go back to this one. So the use case here is if you want to run Threads, all the configuration you have to do with server in the past kind of alleviate now. You can just say Docker run Threads and give it a version, and it will run that Threads version. And there are other flags you can give it to point it at your setup file and in your catalog config file, but that's the basic idea. It also gets to the point where you should read the documentation for each container you actually want to run. The same holds for other applications, ERDAP, GeoServer, Postgres. Any service that you're running is most likely available in a Docker container, and if it's not, we should work together to getting it available in a Docker container. Running pretty over time here. Here's a list of some existing images that you guys might be interested in. And quickly, I'll just give a use case for here at Axiom. Because you might be asking yourself, well, my infrastructure's here and it's set up and it's working, or I'm in the cloud and everything's working dandy. Well, Docker really has the power to simplify your workflows for developing applications and deploying them. Before we were installing applications on bare metal, there were library collisions. There's not really any isolation between any of the services. People would often have a favorite server where they wanted to install everything on, and that server would get overloaded, while other servers sat around and with nothing working on them. So we're transitioning to this, everything is a Docker node. So when we get a new server, we just turn it on, spin it up, install Docker, and that's basically it. Everything that we run is now based on Docker, and we can assume that every server is just running Docker. So it makes managing services and ports and where things are living much, much easier. So with that, I'm going to pass it over to Shane. Sinclair, who will do a little demo.
Can you hear me okay?
Yeah, I can hear you. Everyone else is muted.
Okay.
Yeah, sounds good.
All right. How's the font size on this terminal?
Looking
Everybody
good.
read that? Okay.
No problem. Yep.
Great. So Kyle, keep me on time here. I'm just going to run through sort of some hands-on stuff with Docker that goes over some of the major concepts. So like Kyle said, basically to run any of these containers, you just need to have Docker installed. So there's my Docker. It's 1.11.1. So the first thing, I'm going to try to run just a Debian container. So there's the command line. You run it, interactive mode, and remove it when you're done. So since the Debian container isn't present locally, Docker is going to go out and look at the main Docker hub and download the image. And now I'm running inside this Docker container. So there's the Debian version there. Okay. So that's pretty cool. If I exit back out to my main prompt here, I can just as easily run a CentOS container. So I'll do the same thing, go out and grab CentOS, download the layers, and it's pretty fast about going out and grabbing and extracting the layers, as you can see. And now it's just as easy, I'm inside a CentOS container on the same machine. So that was a pretty eye-opening moment for me to see that you can run any distribution even, in a container. So now we can look at mounting a host volume. So I have this config folder, and inside it there's a file with some data properties in it. So we can mount that from the host container, so you can access certain files inside the container. Now normally the container is completely isolated from the host machine, so it can't access any of the files or ports or anything like that. It's completely run in isolation, but by mounting host volumes into the container, you can access the data. So you can see we've mounted the config file into the data directory on the root, and you can see the same file here. So we can access this configuration file, and we can also write to the data directory. So when we go back out to the host, that file that we just wrote from inside the container still exists. Okay. So if we want to get into something a little more complex, we can start. You can show a simple example of a Dockerfile. So there's a program called Figlet that creates ASCII art from text. And I don't have it installed, as you can see, on my host machine. But we're going to look at, so here's like the most basic Dockerfile you can get. We inherit from the Debian Jessie image. We run apt-get update and install Figlet. And then we clean up some of the app stuff to make the size of the image smaller. And we have a default command that says hello world. So we go back, we build this image, and Docker has just built the image and stores each step in that creation process as a cacheable layer. So it's really fast when you make changes. And now, if we run the image, we get our hello world. So Figlet got installed inside the container and then executed by that command, and then we can feed it other properties to have it say other things. Got a little lag here, okay. So that shows how you can build simple Docker files, not completely useful. So let's look at some other more applicable use cases. So we're looking at, this is the Postgres repository page on the official Docker Hub. So this is where you would go to look and see if your Tomcat or whatever application you're looking for already exists as a community Dockerfile. And this shows there's all these different images. Here's a bunch of different options you can use, setting in passwords and things like that with environment variables. And you can also always look at the Dockerfile itself to see how the community repos are doing it. So here's their very complex Dockerfile that adds a lot of functionality. So back on our terminal, if we want to run Postgres, all we have to do, I'll go over this command line a little bit. We're going to run it as a daemon with this -d. We're going to expose a port, map a port from the host 5499 to the default Postgres port inside the container. We're going to give it a name, and we're going to run Postgres 9.5. So here's the Docker image name and the tag, which is the version. Okay, so that fast, it just spun up a Postgres container, and we can see it running when we list out our running Docker containers. Okay, and we can also see the logs from it. Docker manages all the logs of the containers it runs. So that's the logs from the Postgres server we just started. And we can connect to it from the host on this port that we exposed. Okay, so now we're inside the Postgres container that I just started. So let's look at a slightly more robust case. So right there, we just exposed a port from the local host. You can access that port from other computers on your network on an exposed port. It's just like a port pass-through. Now we're going to run Postgres on an isolated Docker network. So we're going to create a Docker network, and any containers we spin up on that network are going to be able to talk to each other, but that whole app cluster is going to be in isolation. So that means you can spin up really complicated apps that usually expose a ton of ports, but only expose the ports that you want on your system. So first we're going to create this ESIP network, Docker network. And now we're going to run, as soon as I remove this. Okay, so now we're going to run the same Postgres container on the ESIP network, and we're going to store data in volume. And now we can't connect to that Postgres, as you can see here, because the port is not exposed. And we also can't ping that container because it's not exposed on the network generally. So if we connect to another container that's running inside that network, now we're inside a container that's on that virtual ESIP network, and now we should be able to ping the Postgres host. Yep, there it is. And so now we can run an actual PSQL instance on that same virtual network and connect to the Postgres there. Okay. So that's the general idea of Docker networks. You create little isolated virtual networks that you run things in. And we also stored our Postgres configuration in a named volume that time. So that means that other containers can connect to that volume and use that same data. So here I've mounted it in a new Debian Jessie container, but we can see all the Postgres configuration data that we mapped in to that root data directory. So you can share file systems between containers, you can isolate them on networks, you can map in host volumes, and you can expose ports. So let's move on. to an actual functional case. Let me scroll to where that is. Okay. So let's start up a Postgres container. It's derived from the Postgres container, but it actually installs the necessary Postgres components. Okay, so just like that, spun up a Postgres container. We can make sure that it's ready to load data by looking at the logs. Okay, it's ready to accept connections, great. So I'm going to download this world borders data set that some of you might be familiar with. Okay, and then extract that. Okay, now I'm going to quickly create a database inside the Postgres container that we spun up. Better check that syntax. Create a user in a database. And then make sure we enable the Postgres extension on that database so we can load spatial data into it. And create a schema. Okay. Now we can spin up a Docker container in Postgres with the tools that we need. So I've loaded that world borders data into this data directory inside the container. There it is. And now I'm going to load it up with the shaped pg-SQL tool. Okay, just inserted that data there. And now we can verify that it's inside the database here. So there's the GIS database. And you can see our world borders table there. So keep in mind this is all running inside these containers. The only thing installed on my host is Docker. That's the only thing that you would need to run all this. Okay, so now we have spatial data loaded up in a Postgres running in a Docker container. Now we can do something interesting like spin up a GeoServer on the same network and expose port 8888 as a public port. I'm still inside the container. Okay. And now we can check the logs and see that's coming up. There's the GeoServer logs. So now, if we go back and open up a browser, we should see our GeoServer that we just spun up in Docker start up. Yep, and you can see it's loading things in the logs here. Okay, and there we go. Now we can log in. And I've already created a workspace here. And we can actually view the data that we just loaded up. This was just downloaded from the internet a few seconds ago with some simple commands. None of this infrastructure existed before, so you could script this entire process of spinning up, the whole app infrastructure, loading data, and getting to a functional GeoServer. So as you can see, it's pretty powerful. There's a lot of commands to remember and configurations. So wouldn't it be great if there was a way where you could sort of encode all this information into, say, a single file? Well, you can. There's a thing called Docker Compose that helps you organize orchestrations of different containers running together. So the example that I just showed, you could encode all that information in this single YML file. It shows that two services that we want, Postgres and GeoServer. Shows which volumes we want to map, which images we want to execute, the ports we want to expose. So by defining this file, it's as simple as doing Docker compose up and then run it as a daemon. And you can also name the project, which will be used as the prefix, so we'll call it ESIP. And just like that, we have new containers. It's a little messy. Oops. Okay, so you can see we have ESIP GeoServer and ESIP Postgres that were both spun up by that one command. And then if we go here, this is running on 8887. So this is inside that Docker compose execution. And we have the same data running. So sorry if that was a little bit of a whirlwind, but that's the basic idea and shows you some of the power of Docker.
I just have to say that's like kind of jaw-dropping for me anyway. Yeah. That's I mean, I had that same feeling I had when I sing Mosaic for the first time.
Yeah, it really is. I think one of those just, you know, it changes the whole reality of the way we do things. And you can run anything you can imagine. You can run this GeoServer image has been like highly optimized, has special renderers baked into it, but as an end user, you would never know. You just Docker run, and the optimized configuration is deployed for you. It's pretty amazing.
Yeah, that was a great demo.
Dave,
thank you.
Yeah, thank you. All right, Dave, I'm going to hand off to you. Although I don't see you. Kyle, is Dave on?
Ask Kyle.
Oh, okay. There you go.
All right. Can we see we're back on our slides here? It says demo.
Yeah, I can see it.
Good. All right. So Kyle kind of gave you the overview of Docker, its origins, kind of its purpose, and Shane gave you a good working demo of some trivial applications and how you get started with Docker and how you start applying that into a real-world scenario. He showed you how to do it kind of manually, and then he showed you Compose, which is one of the many tool sets available from Docker itself, Docker, the company itself. They've kind of, let's see, how do I describe this? Docker is also Docker Engine. That's kind of the main thing that they originally started with. But then they started, some community stuff started popping up. They started taking some stuff in. They hired a bunch of developers. They started building all these other things. So Docker Compose is one such tool that came out of that. And that's an official Docker-sponsored product now. And that kind of takes you from the service layer, or service level, which is individual Docker images running themselves, to the application level in which you describe your entire application in one shot and bring it all up like that. Another one of the tools that they offer, and we are users of here at Axiom, is called Swarm. Swarm, I think, started as a pretty clever hack, and then they decided that this could really be a thing and used as an orchestration style mechanic. And what they wanted to do was, if you have many available hardware nodes and you wanted to tie those all together and just expose them as if they were one Docker, a virtual Docker engine that you could run anything on. The goal of this would be that you don't care which physical node your piece of software is running on, just as long as it runs somewhere. So this technology called Swarm came about, and this provided this. You could tell Swarm to connect to a whole bunch of other individual nodes, and then all you have to do is talk to the Swarm engine and run containers, and then they'll pop up on those various nodes. Now, it doesn't take care of routing network requests for you. That's handled as an exercise outside of its bounds. So there's some solutions that need to be taken into account at this point. But I wanted to show you how we use Swarm a little bit internally. So I'm switching over to my terminal now. Hopefully you're seeing that. What we're looking at now is that Docker PS, that here's all the running images on two separate remote machines now. These are two machines that are running in our Providence data center. They have no Docker images currently running on them, but we're going to use Swarm to make that happen. If I switch over to this machine here, I'm going to run Swarm, and this command line here, we're going to run Swarm inside of a Docker image itself, which is a bit of a chicken egg thing, but it's funny. It's a nice piece of software that lets you do this. We're exposing port 7777 locally on this machine, which is what this Docker daemon is going to be running on. So we're going to talk to that Docker daemon. And then we tell it at the end, let's manage these nodes. So we're managing Quadium.Axiom Providence and Redstone.Axiom Providence. And I put it on debug mode so you can see a lot of messages come up. So you see at the bottom it registered these engines, and that's cool. So what we're learning now is that when you execute Docker PS like this as a bare command, when you execute Docker PS as a bare command like this, there's an implied Docker daemon it connects to. It's running on localhost. It connects over a Unix socket. These are the ones that I have running locally. So that's what you're going to see here. But you can also tell Docker which one I actually want to talk to. So if I do TCP localhost 7777, which is the one I exposed, and now I'm typing PS, it's now telling me, well, there's nothing running here, and this is a real Docker daemon. It's a very clever way of binding together multiple Docker daemons and making it look like it's just one Docker daemon. So, forgive me one second here. My notes disappeared. There they are. I'm sorry. All right. Okay. So as we're seeing up here, we've got nothing running currently. I'm going to pull a new image down, and we're going to start running those, and we're going to see where they show up. So using the same thing here, I'm going to do a pull of just a hello world image that's out there. What Kyle and Shane didn't show you, when they're doing a run command of an image that they don't have locally, it will automatically do a pull and then do a run step. I'm just doing this manually, so it's saying, okay, I'm gonna pull this image down to each one of these machines, and you can see it's status updating and saying, okay, both Quadium and Redstone don't have this image, so we're gonna pull it down. You don't get the fancy status scrollers like you do, but you do get some updates. So that's just downloaded right there. And I'm already getting sick of having to type that big Docker command out, so I'm gonna alias it. We'll call it dswarm like this. So Docker -h TCP that. So now if I just type DSW, I can just that's a little bit quicker to work with. So let's run one of these instances right now. We're going to do DSW run. I want it daemonized. I want it to expose a port. I don't care which port it is. We'll look it up later. This means that any available port on the host machine will then get mapped down to whatever the exposed ports are on this one image. And
that's cool.
Do it like this. We hit it. We've talked to one of the machines. It gives me back that ID. And if I do a PS now, you notice now we have some output in this thing. It's telling me it's running a hello world image. If you look at the ports mapping, you can see we have a port mapping from 32.773 down to port 80, and then it's running on Redstone. So now if I moved over to my next tab here, which was displaying all the listed ones, so Quadium is on top and Redstone's on the bottom. Redstone is now starting to show something that it's running locally, because using Swarm, we instructed it to do so. So if we wanted to see what this thing is doing, I'll just do it on link so it's easier to see. We know this is Redstone.Axiom PPD. It's running on 32.773. Use -dump. And then boom, we got a hello world. So that's, you could visit this in a browser, for instance, and it will show you slightly prettier. You're seeing my host name is this ID. That also matches the container ID. By default, Docker's host names always match their container IDs. You can override that locally if you want by specifying -- host name. And that's all there is to that. We've now sent this, we've instructed this image to be run somewhere. I don't care which one. Any of those machines is fine. So do that, and we're going to do that again. So now I'm going to say exact same command, run and daemonize any port you got, this image please. Okay, it gives me back another one of these things. So where did that start? Oops, WPS, sorry. Where did that one show up? So that one showed up on Quadium. You see at the top row there, quadium.axiom.pbd. So that's another one. So I can do the same links command for quadium.axiom.pbd, port 327669 -jump, and there it is. Hello world's running. You see the host name is the same, matches the container ID on that one. Now things get slightly interesting when we run a third one, because now we're going to start seeing it's got to pick one of those two machines it's going to run on. Do the PS, we see it. Now we have two running on Redstone. If I switch back over to my individual views over here, then you've got those things. We got two on the bottom on running on Redstone. We got one on the top running on Quadium there. So this is showing how you can interact with these two individual Docker engines via Swarm that we've tied together with the local running Swarm application. One thing to note about this, though, is that the Swarm isn't exclusive. I can individually run another container on one of these machines, and Swarms will know about it, and it will show it as part of its listing, but I didn't have to use Swarm in order to do that. And let me show you here. I'm going to exit out of this over on Quadium, and I'm going to do sudo docker run interactive, remove it, Debian latest. Just get a little interactive shell going, just like how Shane showed you earlier. But if I switch back over and say, hey Swarm, what do you see? We now see that as one of the nodes that's available in there. So it's kind of neat to see that, because the Swarm commands and the thing it exposes operates the same way as a Docker engine would. So you can see, we use this in production internally to run many short-lived IPython notebook instances. You could also consider using something like this for a computational task. If you wanted to spin up an instance which only would chew a number, it doesn't have to be a service, for instance. You could just spin up, do some work, spin back down again. We're also showing you, this is the very basic way of running Docker Swarm, where you specify which hosts you want to run on the command line. There's also more advanced ways in which you can join a new instance. Let's say you got a brand new piece of hardware and you spin it up and you put Docker Engine on there. You can tell Swarm to join an existing one, not the way that we're currently running it, but in a more advanced configuration. You can just have this node joins the Swarm nodes, and suddenly is able to accept, creating of new containers. So that's what I wanted to show you from the Swarm perspective. Here, Swarm is considered an orchestration tool. It allows you to orchestrate many containers, so you can build out applications all over it. This space is exploding in that Docker is a very new technology. Just 2014 really is when it came into the forefront, and all kinds of development is just exploded on it. People are saying, hey, this is a great idea, let's do more with this. And you're seeing all these companies, individuals, all these things come out with tools built on top of Docker to help you orchestrate, as say you have a giant data center where you have all these individual services, like you're a Spotify, for instance. Spotify has Helios. That's their home-built system that they use in order to manage all their running software across all their very large data center. There's Kubernetes from Google, which is kind of in prime position, I would say, as a lot of people are starting to use that now. CoreOS has Fleet. There's Daku. There's New Relic has their own thing called Centurion. Apache Mesos, and then Mesosphere and Marathon built on top of that. So you're talking about there's 1,000 tools out there. We're kind of sitting around waiting for what the dust is going to settle on and what the emerging what the kind of best practices are. But right now there's a lot of competition in this space, and that having that competition there really makes for a better overall product, because they're all trying to solve a similar problem, but they're all iterating on themselves and making themselves better. And I found this guy's blog post. It's fairly recent. He updated it in May. This is kind of like an overview of what is out there in terms of container and ecosystem. Like what exists there. So what I was talking about on the last slide is the second one down here, and I'll use my mouse to point to it. This is that clustering and orchestration area, which I had a bunch of logos from. And then you're talking about, you have a bunch of other things. Kyle talked about the Docker Hub, which exists. There's other ones called Quay. Amazon's computing platform has their own registry style server now that you can use for private deploys. Well, we run our own registry. There's all kinds of software and stuff bringing up all around this, and there's all kinds of interesting best practices that are coming out, and new stuff getting innovated all the time. So it's in flux, but it's not in flux so much as you don't want to touch it right now. We've got a lot of the basics all set. The way you build containers, that's not going to change. All that stuff is really starting to dial in. You're really starting to see a lot of companies use this in production, which is, I think, really exciting, because it's taking a lot of complexity of managing servers and just making it so much easier. With that, turn it back over to Kyle. And
yeah, so that was it that we have for the presentation. I guess we'll take questions now, Rich, or I can't unmute one.
Right, so if you want to ask a question, unmute yourself, and I'll take the liberty of asking the first question, which I've asked this question to Kyle before, so Kyle, you feel free to answer it yourself, or if you want to pass it off to somebody else. But what do you say to somebody who says, "Oh, this sounds great, but our sysadmin said, we're not allowed to run Docker because of security reasons," or something?
I'd say that the answer to that probably change on a week-to-week basis now. I wouldn't give the greatest answer on that, but in general, the concept of containerization isn't new. It's been around since the mid-90s with the introduction of jails into the FreeBSD kernel. Containers in general and jails in particular were built around security to isolate processes and OS processes so they can't interact with others. The way the Docker engine works on top of the Linux kernel is through C groups and namespaces. It is not the most secure implementation. BSD is by far more secure. I would say refer back to your IT guy. Probably knows what he's talking about. We have the benefit of being a private company who can manage our own infrastructure. Our requirements are less strict than, of course, the federal government and things like that. But it is something that the Docker devs get asked a lot, and it's definitely something that they are working on to alleviate those kind of concerns. Shane or Dave, you want to say anything else about that?
I think you got it.
I'll just throw in, other than like 0-day exploits that I haven't really seen any or much of, and those would get stomped out pretty quick. What you do inside the container, like you're basically free to do anything inside your container that you want to. So if you're concerned about security, don't run your application inside your container as the root user. Create another user with limited privileges, and you can set the container to run as that user. It's sort of up to you to lock down what happens in the container if security is a big concern. And also, like Kyle said, running things in containers usually increases security in a lot of ways, because you choose which ports you want to expose. You minimize the surface area contact with the rest of your network, and you segmentize your network instead of just having it open. So it can be good for security practices in a lot of ways.
Yeah, okay, thank you. Yep, that's what it would seem like to me too, just intuitively. But Okay, does anybody else want to ask a question?
Yeah, I got one.
Go ahead. Introduce yourself too, please.
Oh, this is Colin Dietrich. I was wondering what sort of hardware support, like USB, SPI, anything like that, or are there any sort of hooks for that sort of thing to the host?
So Docker exposes, can't think of the actual name of it right now. You can tell, you can run a Docker daemon or a Docker container in privileged mode, which gives you all, what are those things called? I can't think of them now, like this underscore something, something, something. It gives you additional privileges to the hardware underneath. So by default, a lot of those things won't be exposed. Like you won't be able to talk to USB on the raw hardware level, I'm pretty sure, without giving yourself a bit of an additional permission. We ran into issues with that while trying to do some mounting of file systems from inside the containers themselves. You have to give these additional permissions. I'm sorry, I can't think of the name of it right now, but it's a specific Linux kernel, like group permission or something along those lines. One of those things. But you can give a container more privileges, and if you know what you're doing while you're running it, that would probably address those things.
Got it. Okay, thank you.
Okay. Well, if there's no one else, I'd just like to say that as Kyle mentioned, having gone around and helped people install thread servers, and now we have these ERDAP and PyCSW and other services that we'd like to implement in a robust way throughout the IUSE distributed framework. We're going back to those providers and helping them get set up with Docker. And I think this will, as Kyle indicated at the beginning, this is going to lead to a much healthier ecosystem for distributed services, not only for IUSE, but throughout the geosciences, as we all sort of, I feel like we're working together in the ESIP community and beyond on a system that it really relies on robust web services, and if we can make it easier for providers to run those services, then we all benefit. So that was a great demo, guys, and presentation. Really appreciate it. And just one further announcement for a reminder that our next talk is Ken Casey, and please join the is talking about the One Stop project, which actually is also a project about delivering a bunch of data through standardized services. So please tune in for that. And if you have not signed up yet for the ESIP mailing list, or you can either sign up for the overall ESIP mailing list, which we've been posting these to, but if you want to just get the just sign up for interoperability and technology, please sign up on the page. So, all right, thanks again, everybody, and we'll see you in a month.
Thank you.
Thank you.
Annie?
Yeah. Can you hear me?
Yeah.
Okay, great. I have this spinning wheel of death on my computer just going round and round, so I haven't been able to manipulate anything, so I'm logged in on my other machine here.
Okay.
So anyway, so I will I'll send you the link to where the recording is.
Okay. And then I take it from there, because I've been converting it to YouTube.
Perfect.
Yeah.
Yeah, perfect. Okay, great. Well, I will send you the link as soon as it's up.
Okay.
Okay. Great.
How did you think that went? How did you think that? Well, I guess it's hard to. I think that went. That's pretty cool.
Yeah.
I'm not sure if it was. I'm not sure if it was too nerdy for folks, but I didn't see that many people dropping off during the. During the talk. So I think people were at least curious enough to just see what's going on there.
Yeah. No, I thought it definitely was it definitely had a requirement of some base level knowledge, but I would assume that the crowd that would sign on was kind of that group. So no,
yeah,
I like the
it looked like it. Yeah. All right. Well, thanks very much.
Yeah. Okay. Well, I'll be in touch.
Okay. Thank you again. Bye-bye.
Bye.